Now, in this video, we're going to talk about how to calculate the surface area of a solid when rotating the curve about, let's say, the x-axis or even the y-axis. So here's the formula. The surface area is equal to 2 pi integration from a to b times the radius in terms of x multiplied by the square root of 1 plus f prime of x squared times dx. So that's the formula we're going to use. So let's try a problem. Let's say that the curve is y is equal to x cubed, and it's bounded by the x values from 0 to 2. And we're going to rotate it around the x-axis. Calculate the surface of the solid that is formed when it's rotated about the x-axis. Find the surface area. So let's draw a graph. So we just need to focus on the right side of the graph. So this is 0, this is 2. The radius is between the curve and the axis of rotation. So that's the radius. It's rotating about the x-axis. So as you can see, the radius is parallel to the y-axis, so r is equal to y. Now we want the radius to be in terms of x, and y is equal to x cubed, so r of x is x cubed in this problem. Now, if y is equal to x cubed, that means f of x is x cubed, and f prime of x is going to be 3x squared. Now, what we need to do is we need to square both sides. We need to find the square of f prime of x. 3 squared is 9. X squared is going to be x to the 4th. Now, let's plug in everything into the formula. So we can see that a is 0, b is 2. So the surface area is going to be 2 pi integration from 0 to 2. R of x, that's x cubed, and then times the square root of 1 plus f prime of x squared is 9x to the 4th, and then times dx. So let's clear away a few stuff before we continue. So how can we integrate this expression? What techniques can we use? The best technique that we can use is u-substitution. Let's set u equal to 1 plus 9x to the 4th. du is going to be 36x to the 3rd, that's the derivative of 9x to the 4th, times dx. Now solving for dx, it's du divided by 36x to the 3rd. So now let's go ahead and replace 1 plus 9x to the 4th with u. Now the square root of u, we can write it as u to the half. And dx, we can replace that with du divided by 36x cubed. Now we need to change the limits of integration. We've got to change these numbers. So when x is 0, let's use this equation. We've got to find the value of u. So it's going to be 1 plus 9 times u raised to the 4th, which is just 1 plus 0, so that's 1. Now, if we plug in 2 to the 4th is equal to 16. And 9 times 16, that's going to be 144. Plus 1, that's 145. So now this is what we have. So this is going to be 1, and the top number is 145. And we can cancel x cubed. So let's move the 36 to the front. and it's on the bottom, so this is going to be 2 pi divided by 36, and then we have u to the half du. So now let's find the antiderivative of u to the 1/2. 1/2 plus 1 is 3/2. So it's going to be u raised to the 3/2, and instead of dividing it by 3/2, let's multiply it by 2/3. Now 2 pi over 36, that reduces to pi over 18. We're going to evaluate this from 1 to 145. Now 18, we can break that up into 9 and 2. So these 2's will cancel. Next, let's multiply 9 times 3, that's 27. So what we have right now is pi divided by 27, u to the 3/2, evaluated from 1 to 145. So that's what we currently have. So now let's finish the problem. Let's go ahead and plug in 145 and 1. So this is going to be 145 to the 3/2 minus 1 to the 3/2. 1 raised to anything is 1. But now what exactly is 145 to the 3/2? Well, we can split up the exponent like this. 3/2 is basically 1 plus a half. Whenever you multiply by a common base, you can add the exponents. So 145 to the first power is simply 145. 145 to the 1/2 power is the square root of 145. So this is the answer. Now, if you want the answer as a decimal, that expression is approximately equal to 203.044. Now, let's try another example. So let's say that y is equal to the square root of 4 minus x squared. And we want to find the surface area when this curve is rotated around the x-axis, and it's bounded by the x values -1 and 1. So go ahead and try this problem. The square root of 4 minus x squared is basically a semicircle. It's a semicircle with radius of 2. And let me draw that better. That does not look like a semicircle. Now we only want the region starting from -1 to 1. When x is 2, y is 0. But we don't need to go that far. So we're only concerned about this area here. So let's identify the radius. The axis of rotation is the x-axis. So the distance between the curve and the x-axis is the radius. So once again, we can see that the radius is equal to y, but we need it in terms of x. And y is equal to the square root of 4 minus x squared. So that's r of x. Now, r of x is basically the same as f of x in this problem. F of x is 4 minus x squared to the 1/2. Now let's find the first derivative. So f prime of x is going to be 1/2. Keep the inside the same, 4 minus x squared. Subtract the exponent by 1. 1/2 minus 1 is -1/2. And according to the chain rule, we need to find the derivative of the inside. The derivative of 4 minus x squared is -2x. Now let's simplify the expression. 1/2 and 2 will cancel. So f prime of x is equal to -x divided by, because the exponent is negative, we can make it positive by moving 4 minus x squared to the bottom. So this is square root 4 minus x squared. Now we need to square both sides. We need the square of the first derivative. And so f prime of x squared, that's going to be -x squared, or -x times -x is +x squared. Whenever you square square root, these will cancel. So it's just going to be 4 minus x squared. Now we can write the expression for the surface area. It's going to be 2 pi integration from -1 to 1, r of x, which is square root 4 minus x squared, and then times the square root of 1 plus the square of the derivative, which is x squared, over 4 minus x squared, times dx. So before we continue, let's just delete a few things. Now what we're going to do is we're going to take 4 minus x squared and distribute it to these two terms. Because we have two square root functions, we can multiply the things that are on the inside. So 4 minus x squared times 1 is simply 4 minus x squared, all inside the square root. So we can just combine the two small square roots into one big square root symbol. Now 4 minus x squared times x squared over 4 minus x squared. Notice that the 4 minus x squared terms will cancel, leaving behind just x squared. So this is going to be plus x squared and then times dx. Negative x squared plus x squared, these will cancel, they add up to 0. So we have 2 pi integration from -1 to 1 square root 4 dx. The square root of 4 is equal to 2. And the integration of 2 dx is simply 2x. Two pi times 2 is 4 pi. So we have 4 pi times x evaluated from -1 to 1. So now let's replace x with those numbers. So first let's plug in the top number 1 and then minus the bottom number -1. 1 minus -1 is the same as 1 plus 1, which is 2. So it's 4 pi times 2, and so the final answer is 8 pi. And if you want to convert that to a decimal, that's going to be about 25.133. And so that's it for this problem. Now, let's try another one. Let's say that x is equal to 1/3 y squared plus 2 raised to the 3/2. And y is going to be between 1 and 2. And we're going to rotate this region about the x-axis. Go ahead and figure this out. Now it turns out that we really don't need to know exactly how the curve looks like. All we need to know is the axis of rotation. The curve is rotating around the x-axis. Let's say it looks something like this. Now because we have x in terms of y, we're going to integrate it using y values, that is from c to d. The formula is going to be 2 pi integration from c to d. The radius is going to be in terms of y, and then times the square root of 1 plus g prime of y, but squared. So everything looks exactly the same, but it's just in terms of y instead of x. But you get the same answer. Now the radius, it's still the distance between the curve and the axis of rotation. And the radius is parallel to the y-axis, which means that the radius is equal to y. Now we want the radius to be in terms of y, so we don't have to solve for y. R of y in this problem is simply equal to y. In the other examples, the radius was already y, but because we wanted r of x, we needed to get it in terms of x. But here, it's still equal to y, but it's already in terms of y, so we're going to leave it like that. Now let's focus on g prime of y. G prime of y is equal to dx over dy. And f prime of x rather, that's dy over dx, which we dealt with in the last two problems. Let's find dx over dy by taking the derivative of this function where x is by itself on one side of the equation. So if x is equal to everything on the right side, then dx over dy is equal to 1/3 let's move this to the front. So 1/3 times 3 over 2. Keep the inside the same. And then subtract the exponent by 1. 3 over 2 minus 1 is 1 over 2. Next, according to the chain rule, differentiate the inside. The derivative of y squared plus 2 is 2y. So now we can cancel a 3 and we can cancel a 2. So dx over dy, which is basically g prime of y, that's equal to y times this thing, which is the same as the square root of y squared plus 2. Now what we need to do next is we need to square both sides. So y to the first power raised to the second power, that's going to be y squared. And once we square a square root, the square and the square root will cancel, giving us y squared plus 2. And if we distribute y squared, it's going to be y to the fourth plus 2y squared. So that's g prime y squared. So let's just write down what we have. R of y is y, and g prime y squared is y to the fourth plus 2y squared. And y is between 2 and we said 1. So now let's use the formula. S is going to be 2 pi integration from c to d, or from 1 to 2. And then it's r of y, which r of y is just simply y. And then square root 1 plus g prime of y squared, which is y to the fourth plus 2y squared. And then times dy. So now let's rewrite the stuff inside the radical, but in standard form. So that's going to be y to the fourth plus 2y squared plus 1 times dy. Notice that it's a perfect square trinomial. If you have a perfect square trinomial in the form a squared plus 2ab plus b squared, this is equal to a plus b squared. So y to the fourth is a squared, which means a is simply y squared. B squared is 1, which means b is 1. So we can factor this trinomial and write it as y squared plus 1 squared. So what we have is this, 2 pi integration from 1 to 2 y times the square root of y squared plus 1 squared dy. So we can cancel the square root and the square, giving us this expression. Now let's go ahead and distribute y to y squared plus 1. So that's going to be y cubed plus y times dy. So the antiderivative of y cubed is y to the fourth divided by 4. And the antiderivative of y to the first power is y squared over 2 evaluated from 1 to 2. And let's not forget to multiply the whole thing by 2 pi. So let's plug in 2. So 2 to the fourth power, 2 times 2 times 2 times 2, 4 times, that's 16. And 2 squared is 4. Now if we plug in 1, 1 to the fourth power is just 1, so we're going to get 1 over 4. 1 squared is also 1, so plus a half. And then we're going to multiply everything by 2 pi. So 16 over 4 is 4, and 4 divided by 2 is 2. And then we have minus 1/4 and minus 1/2. 1/2 is the same as 2 over 4. Now 4 plus 2 is 6. Negative 1/4 minus 2/4 is negative 3 over 4. Now what we need to do is get common denominators. 6 over 1, let's multiply it by 4 over 4. So this is going to be 2 pi. 6 times 4 is 24. And 24 minus 3 is 21. Now 4 divided by 2, if you divide it backwards, is 2. So we're going to have a 2 in the bottom. So the answer is 21 pi over 2. That's the final answer. That is the surface area when rotating the curve about the x-axis from y equals 1 to y equals 2. Now let's work on an example where we're going to have the function in terms of x, but we're going to rotate the curve about the y-axis. So let's say that y is equal to negative 1/4 x squared plus 1. And we want it between the x values 0 and 2. So if you see a range of x values, then you want the radius to be in terms of x. So you want everything to be in terms of x. And we're going to rotate this about the y-axis. Negative x squared opens downward. And if you have a plus 1, it's going to be shifted 1 unit up. And we only need the right side of the graph. So this graph is going to look something like this. The x-intercept is 2. When x is 2, y is 1. So this is the shaded region from 0 to 2. Now, because the axis of rotation is the y-axis, the radius is the distance between the y-axis and the curve. So it's parallel to the x-axis, but perpendicular to the y-axis. Because it's parallel to the x-axis, the radius is equal to x. And we want it to be in x. We want it to be in terms of x, so we're not going to change it. Now, f of x is negative 1/4 x squared plus 1. So now let's go ahead and find f prime of x. That's going to be negative 1/4. The derivative of x squared is 2x, and the derivative of 1 is 0. So negative 1/4 times 2x is basically negative 1/2 x. Now let's square both sides. Let's find the square of the first derivative. So negative 1/2 x squared, negative 1/2 times negative 1/2, that's positive 1/4. X times x is x squared. So that's what we have. Now the surface area is going to be 2 pi integration from a to b, or 0 to 2. And then it's going to be r of x, which r of x is simply x times the square root of 1 plus f prime of x squared, which is 1/4 x squared, and then times dx. So now we just need to do the math. So we're going to use u-substitution. Let's make u equal to 1 plus 1/4 x squared. So du is going to be 1/4 times 2x, which is 1/2 x times dx. If we multiply both sides by 2, 2 du is equal to x dx. And solving for dx, dx is going to equal 2 du divided by x. So the surface area is going to be 2 pi integration from 0 to 2. Well, we need to change those values using this equation. So when x is 0, u is equal to 1. And when x is 2, u is going to be 2 squared is 4 times 1/4, that's 1, plus 1, u is going to be 2. So the new values are 1 and 2. Now let's go ahead and plug in what we have. So 1 plus 1/4 x squared, that's u. So instead of writing square root u, we're going to write 1/2, u to the 1/2. And dx is 2 du over x. So let's cancel x. And let's move this 2. Let's combine it with 2 pi. So this is going to be 4 pi. Antiderivative 1 to 2. And then u to the half for du. Now the antiderivative of u to the half is u to the 3 over 2 times 2/3. Four pi times 2/3 is 8 pi over 3. And if we plug in 2 and 1 into u to the 3 halves, it's going to be 2 to the 3 halves minus 1 to the 3 half. 2 to the 3 half is basically 2 to the first power times 2 to the half. So that's 2 square root 2. Now we can write the answer like this, or we could distribute the 8 if we want to. 8 times 2 is 16. And so it's going to be 16 root 2 minus 8. So you can leave the answer like that. Now the decimal value of this answer is about 15.318. So this is the solution. So this is going to be the last example for this video. Let's say that y is equal to the cube root of x, and the y value ranges from 1 to 2. Let's rotate the region about the y-axis, and let's calculate the surface area. So the graph of cube root of x, just the right portion, looks like this. On the left side, it looks like that, but we only need the graph from 1 to 2 on the y-axis. So let's say this is 1, and this is 2. Now we're going to rotate the curve about the y-axis. So therefore, this is r. R is the distance between the axis of rotation and the curve. So because r is parallel to the x-axis, r is equal to x. But notice that the range consists of y values, which indicates that we want r not in terms of x, but in terms of y. So somehow we have to use this equation to get r in terms of y. So y is equal to the cube root of x. So let's raise both sides to the third power. We need to solve for x. So these will cancel, and we can see that x is equal to y cubed. So if the radius is equal to x, then the radius is also equal to y cubed. Now let's focus on g prime of y. So using this equation, if x is equal to y cubed, then dx over dy is equal to 3y squared, which is the same as g prime of y. Now we need to find g prime of y squared. So that's 3y squared, which is 9y to the fourth. So now let's write the equation for the surface area. Let's set up the integral. It's going to be 2 pi integration from c to d, which c is 1, d is 2. So from 1 to 2. And then it's r of y, which is y cubed, times the square root of 1 plus g prime of y squared, which is 9y to the fourth, times dy. So once we set up the integral, now we just got to worry about the math part. So let's use u-substitution. Let's make u equal to 1 plus 9y to the fourth. So du is going to be 36y cubed dy. Solving for dy, it's going to be equal to this thing, du over 36y cubed. Now we need to change the x values into u values using this equation. So, when y is 1, I said x values, but I meant y values. When y is 1, u is going to be basically 10. And when y is 2, 2 to the fourth is 16. 16 times 9 is 144 plus 1. That's 145. So the surface area is going to be 2 pi, 10 to 145, y to the third, u to the half, and then dy is this. It's du over 36y cubed. So let's cancel these two. And let's take this, move it to the front. 2 pi divided by 36 is basically pi over 18. The antiderivative of u to the half is u to the 3 over 2 times 2/3. Now we know that 2 over 18 is going to be 1 over 9. And 1 over 9 times pi over 3 is pi over 27. And then we're going to evaluate this from 10 to 145. So this is going to be pi over 27, and then 145 raised to the 3 over 2 minus 10 to the 3 over 2, which we know it's going to be 145 square root 145 minus 10 square root 10. So this is the exact answer. The decimal equivalent is going to be, it's approximately 199.480. And so that's it for this video. Thanks for watching.